Hello and welcome to our ventilation demonstration for reducing risk when entering confined space manure storages. We would like to show you some of the dangers associated with manure pits and ways to reduce these dangers. Your presenters today are with the Department of Agricultural and Biological Engineering at the Pennsylvania State University. We will begin with an initial demonstration involving a slotted floor facility with low yet dangerous manure pit gas levels. Toxic, asphyxiating, and explosive gases are the most dangerous hazards in confined space manure storages. Between 1975 and 2004, 65 fatalities were reported in confined space manure storages. Tragically, these incidents often include multiple victims because one person attempts to rescue another already unconscious person who is usually a family member or a co-worker. These would-be rescuers may think they can hold their breath and quickly rescue an unconscious person, but experience shows it just doesn't happen this way. Our demonstration today will take place inside this trailer. We would like to help to identify hazards, show how to monitor for these hazards, and then how to reduce risk when entering manure pits. We will show you the effectiveness of a properly designed and used ventilation system to reduce the risk associated with contaminant gases and oxygen deficiency. In particular, we want to demonstrate how to reduce hydrogen sulfide, one of the most toxic manure gases, from an extremely dangerous concentration to the OSHA-recommended 8-hour exposure limit of 10 parts per million. I will first give you a brief overview of our demonstration by pointing out some of the components of our model. It uses an 8-foot long by 4-foot wide by 2-foot deep plexiglass enclosed model to simulate an 80-foot long by 40-foot wide by 10-foot deep underground enclosed manure storage pit with a slotted floor above. Above the pit and slotted floor is the barn and animal living quarters. This barn area has an exhaust ventilation system totally independent of the pit ventilation system. It consists of air inlets on the left side and 2 exhaust fans on the right side. We have a personnel entry point or a manhole where farmers can enter the pit to work or retrieve tools. Our ventilation pit fan is located near this personnel entry point. We have 3 gas sensors located to the left, center, and right, which are used to monitor gas levels inside our facility. Red strobe lights are now flashing to identify the locations of these gas sensors. We have 2 sensors, left and right, beneath the slotted floor inside the manure pit, with the center sensor located inside the barn on top of the slotted floor. This allows us to measure toxic gases in 3 different locations. Gas concentrations measured by each sensor are displayed on the 3 lighted LED displays at the top of the model. You will notice that the gas concentrations are reported in units of parts per million, labeled as ppm on the overhead displays. 1 part per million of toxic gas is equivalent to 999,999 parts of air and 1 part of toxic gas. Right now you can see that our sensors are reading 0 because there is contaminant-free air inside our model. Next, let's talk a little more specifically about manure gas hazards. The 4 primary manure gases are hydrogen sulfide, carbon dioxide, ammonia, and methane. Hydrogen sulfide is one of the most dangerous of the manure gases. It is colorless, has a rotten egg odor, and deadens the sense of smell at approximately 100 parts per million. Warning: the rotten egg odor can easily be covered by other common farm smells. The OSHA recommended exposure limit is 10 parts per million for an 8-hour workday, and it is immediately dangerous to life and health at just 100 parts per million. Notice that this is the same concentration as when you can no longer smell the gas. Concentrations of hydrogen sulfide near 1,000 parts per million and higher will paralyze breathing muscles in a matter of seconds, resulting in a quick death. This is why we consider hydrogen sulfide to be one of the more dangerous manure gases. Carbon dioxide is a colorless and odorless gas that is dangerous because it displaces oxygen. Without the proper amount of oxygen to breathe, we can very quickly become disoriented and lose consciousness. Our third gas is ammonia. It is colorless and has a pungent odor at relatively low concentrations. It is very irritating to the eyes and throat at low levels, and it usually drives people away from the area before it becomes lethal. Methane is a colorless and odorless gas and presents a serious fire and explosion hazard. At high levels, it displaces oxygen and asphyxiates, but it is primarily an explosion hazard. And we don't want to forget oxygen. The air that we are breathing right now contains approximately 21% oxygen, and this gas is necessary to sustain life. The minimum allowable level is only 19.5%. As oxygen levels decrease, we become disoriented, confused, and short of breath, and we would quickly lose consciousness if the oxygen level dropped below 10%. We are now filling our pit with theater fog, and for safety purposes with a non-toxic gas instead of the highly toxic hydrogen sulfide. This non-toxic gas has the same ventilation characteristics as hydrogen sulfide, so it behaves the same way when we ventilate the manure storage. I'll continue to refer to this non-toxic gas as hydrogen sulfide for the rest of the demonstration. Notice that we are beginning to see the gas concentration readings on the left and right LED displays change as the gas fills the pit area first. Also, please note that it is becoming harder to read the banner and to see the strobe lights as our pit fills with theater fog. We are using the theater fog to help you see the effects of ventilation later in this demonstration. We have just turned on our barn ventilation fans. Watch as they remove contaminated air from the barn. Air is flowing from the ventilation inlets at the left end of the barn through the ventilation fans on the right side of the barn. Notice that although gas levels are high in the pit, the barn is registering little or no hydrogen sulfide at the present time. Although we had the barn fans running, they have done almost nothing to remove the fog and toxic gas in the pit. This is because natural ventilation and barn ventilation are not sufficient to remove toxic manure gases from a manure pit. A second ventilation system is needed to force air into the manure storage to remove the toxic gases before a worker enters the pit. We have now turned on the pit ventilation fan to force the toxic gas out of the storage. Watch carefully as fresh air is introduced into the left end of the pit and forces the fog and hydrogen sulfide up through the slots in the floor and then out through the barn ventilation fans. We can see that the red lights and labels inside the storage are becoming easier to see. We also notice that the two sensors located in the pit, the one on the left and the one on the right, are beginning to register low levels of hydrogen sulfide. However, the center LED display is rising, indicating that the sensor above the pit on the slotted floor is measuring some toxic gas. This demonstrates that if you have a slotted floor confinement system, you have to be aware that ventilating the pit below is likely to increase the level of toxic gas in the barn above it. If you have livestock in the barn, this could be a serious problem depending on how high the level increases and how long it stays at this high level. According to OSHA, as long as the gas never reaches above 50 parts per million for more than 10 minutes, livestock in the barn should be okay. I say should because there are too many variables for anyone to say they would be completely safe in all circumstances. These variables include the size of animals and their position in the barn. For example, a 1,000-pound cow will be better off than a 100-pound pig. For that matter, a 100-pound pig near an exterior wall is better off than the same size pig in the center of the same barn. This is why having and using gas monitoring equipment is so important. Without it, you are taking chances with human lives and the lives of your animals. The fog and gas decreased at the left end of the pit first, near where the pit ventilation fan is located. You have now seen that the banner at the back of the pit is more visible than earlier. We are seeing that the pit ventilation fan is very effective for removing contaminated air from the manure pit. Both ventilation fan systems will continue to run in the barn and the pit to clear out the contaminated air. This demonstration is based on our model. Ventilating a real slotted floor pit under a barn can take 15 minutes or more, and the only way to know if the concentration is below 10 parts per million is by using a gas monitor. If we didn't have these two gas sensors in the pit and the one on the slotted floor, we would have no idea what level of toxic gas was in our pit and in the barn on top of the slotted floor. As the gas concentrations inside the barn and the pit decline, we are reaching our goal at least of 10 parts per million. More ventilation may be required to reach this goal. We have some suggestions and important tips for when you must enter a confined space manure storage pit. Training is very important, and everyone on the farm should understand the hazards of various confined spaces that exist at the work site. They need to understand what to do and what not to do in case of an emergency involving a manure storage pit or any confined space. They should be especially cognizant of the following steps. You must ask a second person to work with you and watch as you work in the pit. However, the second person should never enter the pit, even in an emergency. If the second person attempts a rescue, he or she would be overcome by gas just as quickly. Workers and co-workers should test the atmosphere inside the pit for dangerous gases using a handheld gas monitor. We will show you one of these devices shortly. The manure pit should be ventilated with forced fresh air before anyone enters. Keep the fans running while work is being done. A tripod lift with harness and fall arrest system is critical in the event of an emergency. A worker can be easily and safely lifted from the pit by a co-worker. This brings us to the second part of our manure storage ventilation simulation today. We would now like to show you a demonstration of a more dangerous situation. This simulation will again demonstrate why gas monitoring equipment and the use of a well-designed ventilation system are so important. This time we are filling our manure pit to a higher level of hydrogen sulfide. We will soon see the gas concentrations rise on our 3 gas sensors. This time the gas will stabilize at much higher concentrations inside the pit. Remember, we cannot see these gases because they're colorless, but we can see the concentrations rising on our LED displays. I am close to the model inside our trailer and notice that the pit looks clear. I don't see any, nor can I smell any gas. Although the pit looks okay, the only way to know is to check the atmosphere inside the storage with a gas detection monitor. But let's show you the consequences of not monitoring for gas levels inside the pit. Farmers are often under pressure to finish jobs quickly and may overlook safety precautions when entering a manure pit. They may behave like our foolish Freddy and enter without monitoring the toxic conditions in the manure storage. Let's see what happens when he enters the manure pit to repair an agitator. As we can see, foolish Freddy is carefully descending the ladder into the pit. He has just passed out near the bottom of the ladder and is now unconscious on the floor of the storage. This is a very bad situation for foolish Freddy because he is unconscious in an atmosphere filled with hydrogen sulfide. You will remember that one of our suggestions before entering a manure pit was to use a handheld gas monitor. We will now show you how to use an electronic handheld gas monitor to test air quality. This monitor is small, a compact model that measures hydrogen sulfide. Right now we are holding the handheld monitor in fresh air, and it indicates that the air is safe. We will now use the monitor with the hose as a probe to sample the air inside our manure pit near where Foolish Freddy is laying. During this short wait, please remember that your gas monitor should always have a charged battery and be carefully calibrated according to the operator's manual. The alarm is indicating that the atmosphere is not safe for human entry. The gases must be removed and oxygen replenished before anyone attempts to enter. If Foolish Freddy had used this device before entering the pit, he would have known the dangerous environment that he was about to enter. Remember that earlier we identified 100 parts per million of hydrogen sulfide as immediately dangerous to life and health? Since we have the three sensors inside the model, we know that inside the pit, hydrogen sulfide is present at very high levels, well above the 100 part per million level. If any person tried to enter the manure pit with these current atmospheric conditions, they would collapse and almost immediately die. With the higher gas levels in the pit, we also notice that the concentration inside the barn is pretty high. In fact, it is much higher than our safe threshold of 10 parts per million, or the level that is dangerous for even short periods of time. As in our previous demonstrations, we have again turned on the barn ventilation fans. We will soon see that the gas concentrations inside the barn begin to decrease slightly. As we saw earlier, the barn ventilation is effective in removing some of the toxic gases from the livestock housing area, but we know that this will do little to remove the toxic gases from the manure pit. We have now turned on the manure pit ventilation fan just as we did in the first demonstration. We notice that the toxic gas concentrations inside the pit are very high, in fact much higher than in our first demonstration. With the manure pit ventilation fan now on, pay close attention to the center LED display, which is measuring the gas concentration inside the barn on top of the slotted floor where your animals are housed. Notice how the gas concentrations above the slotted floor are rising. This demonstrates that if gas concentrations inside a pit are extremely high, it will be necessary to evacuate livestock before ventilating the pit to keep them alive. Even though the barn ventilation fans are running at full capacity, they cannot move enough air to prevent this sharp spike of hydrogen sulfide inside the barn. The concentration levels we are seeing would be very dangerous to both workers and livestock, even for a short period of time. Since we cannot see the gases, we do not know what concentrations are present inside a manure pit without monitoring equipment, which is, of course, why we keep mentioning it. And remember, at these high concentrations, we won't be able to smell the toxic gas either. As the hydrogen sulfide continues to be evacuated from the pit and barn, let's talk for a moment about the ventilation of solid cover manure pits. Our current simulation uses a slotted floor barn with a manure pit beneath. But some manure pits are located underground with solid covers. Evacuation times for solid storages are slightly shorter than for slotted floor storages. Ventilation fans and ventilation outlets should be located at opposite ends of a solid covered pit to create a tunnel effect during ventilation. This will help ventilate all areas inside the storage. Manure pit ventilation for all types of manure pits should be a positive pressure system. This forces fresh air in and contaminated air out of the pit. This is faster and more effective than a negative pressure system that attempts to pull air out of the pit. Ventilation times for most solid cover manure pits range from 4 minutes for smaller pits to 10 minutes for larger pits. Ventilation for slotted floor pits can be as long as 15 minutes or more. We now see that our hydrogen sulfide levels inside the pit and inside the barn have met or are approaching our goal of approximately 10 parts per million. I should remind you that this simulation today used a model that ventilates more quickly than a full-size manure storage facility would. And please remember, both the pit and barn ventilation systems should continue to operate during any work or rescue activities. As we continue to ventilate, I would like to move on to some additional important tips. It is very important to empty the storage so it contains less than 6 inches of residual manure. Before you enter a manure pit, use a monitor to check for potentially dangerous atmospheres and continue to monitor while inside the pit. This type of equipment can be borrowed, purchased, or rented. Ventilate the pit prior to entry to remove the toxic gases. When the manure pit is being ventilated, barn ventilation should also operate at maximum capacity. Ventilate the livestock housing at the hot weather rate prior to and when the manure pit ventilation is running. Continue pit and barn ventilation while working in the pit. Livestock and personnel may need to be removed from the animal living quarters prior to ventilating the manure pit, especially if the hydrogen sulfide concentration in the pit is approximately 80 parts per million or higher. Never work alone. Your co-worker should never enter the pit. He or she needs to be able to respond in an emergency. And our final tip is to use a tripod and harness with a self-retracting lifeline so that your co-worker can remove you in an emergency. We will now move on to part 3 of the slotted floor video. Our third simulation will focus on the introduction of contaminant-free air into our manure pit by using a dedicated air duct, also known as an air induction system. Our barn ventilation system is currently operating. We have been in the trailer that houses our model and have attached an air duct to the manure pit ventilation fan. Our objective for this third slotted floor demonstration is to show you the increased effectiveness of introducing contaminant-free air from an outside source. The air duct tube that we have attached to the manure pit ventilation fan is designed to take fresh, uncontaminated air from outside of the livestock confinement building and force it into the manure storage pit. As the contaminated air is forced out of the pit up into the barn, it will then be removed by our barn exhaust fans or a negative pressure ventilation system on the right side of the model. Before we begin introducing the fresh air through the duct, you will notice that the levels of hydrogen sulfide have increased in the pit. Our goal with this low concentration demonstration is to reach in excess of 100 parts per million before we turn on our manure pit ventilation fan with the fresh air duct. As you can see, it is now well above the 100 parts per million level. Once the manure pit ventilation fan with the attached air duct begins forcing fresh air into the pit, I would like you to take notice of the decreasing level of hydrogen sulfide in the pit and an increase in the levels above the slotted floor where our third gas monitor is located. We will now turn on the pit ventilation fan. As noted earlier in the non-ducted simulation, this can be a dangerous situation for workers, family members, and animals that are in the livestock confinement area above the slotted floor, meaning that people and livestock may need to be out of the barn area before any pit ventilation begins. Let's continue to watch as the manure pit gas levels decrease and the livestock confinement area gas levels initially increase. They will eventually stabilize and then begin a slow decline to safer levels as the barn ventilation fans remove the contaminated air that has been forced up out of the manure pit. You will note that the introduction of pit ventilation air through the ducted air system has resulted in reducing air contaminant levels in the pit more quickly than when we were using the less than fresh air from the enclosed barn environment above the slotted floor during our first simulation. In these demonstrations, our timing of the two low concentration simulations indicated that the ducted air system took nearly 20 to 40% less time in reducing the hydrogen sulfide content in the barn area to a safe 10 parts per million level. As we continue to ventilate the pit and barn with inducted fresh air, let me reinforce some very important safety guidelines. Without using manure gas monitoring equipment and installing and using a positive ventilation system like the one we have demonstrated today, you would need to wear an expensive and difficult-to-use self-contained breathing apparatus, or an SCBA, to rescue a person who has foolishly entered and become unconscious in a manure pit. On the other hand, a cartridge-type respirator like the one we are showing will do absolutely nothing to protect you. This concludes our demonstration. If you would like more information about confined space gas hazards, ventilation systems, or gas and oxygen monitoring equipment, you're welcome to visit our website at www.manurepitsafety.psu.edu. Thank you very much for watching our demonstration today.